Hello everyone and welcome to my channel where I'm documenting my journey through the ST microelectronics universe. Today's video is going to be about blinking the backlight of the LCD module on the STM32 F469i discovery board. This should be something easy because it resembles blinking some other types of LEDs which I've been doing so far on this channel. So yeah, I started right away doing my very first Google search to kind of find ways to toggle this LED. And it yielded some interesting results. So I discovered there was a pin called LCD backlight control. And this pin was also found on the STM32. So it was labeled exactly like that. So I started playing with it. And I started pulling it high or low, and according to this screenshot, to this data sheet screenshot, I should be able to turn the backlight on and off when playing on the LCD backlight control pin. So I started doing exactly that, but the issue is it didn't really work. So I decided to not use Google search, and I decided to go directly to check the data sheet of the board. So I started looking at the schematics, and one interesting thing that I found out was that I found the LCD backlight control pin again, and the only difference between this screenshot and the previous one was this red cross here, which was indicating the absence of resistors in this area of the circuit, which means that when I was toggling the LED backlight control pin up and down, it was doing nothing because it was basically disconnected from the rest of the circuits, so it wasn't doing anything. And I discovered that there is this integrated circuit that was directly driving the backlight through these pins, LED A and LED K. And the only way that I would be able to drive this or control this integrated circuit was through the CIBC signal instead of using the LCD backlight control signal. So I did exactly that, and I started looking for the CIBC. Yeah, CIBC is short for content adaptive brightness control. And it's well, as far as I was concerned, when I was looking at the signal here, CIBC, I thought it was just another pin that I needed to toggle up and down instead of another one. So I tried doing that, but it didn't really work because the CIBC pin was nowhere to be found. I couldn't interact directly with it anyway. So at this point in time, I just decided to download a board example called LCD Paint and running it on my board. That way I could use the code that is official from STM and study it a little bit to kind of understand what's going on with the LCD when it's operating. So I did that and started running it and tried running it, and of course it didn't work. It failed. It took me some time to understand that there was something wrong with my project settings and something different about my board. And that thing is the processor flag. What's happening on the STM32 F469i discovery board is that it's not just one board, it's actually three versions. There is revision A, revision B, and then revision C. And when I was running the LCD Paint example on my board using QIDE, it was compiling for revision C, and that's why it didn't work. So I just went to the preprocessor flags and set the correct one, which is revision B, and just saved and ran the code again. And yeah, surprise, it worked. And this was pleasing because this is the very first success after a series of fails. So once this worked, I started looking at the code and doing the reverse engineering of the code. And it took me a lot of time to understand what goes on because there were a lot of drivers involved, a lot of header sheets or header files involved, and a lot of portions of the code that were being called every now and then, and I needed to make sure that I understood most of it. So once that was done, I decided to strip the code down to basically boil it down to only the portion that is directly related to the backlight control. And on the process of doing that, I discovered something called the MIPI DSI protocol, because it so happens that my LCD was using this protocol to communicate between the microcontroller and the board, microcontroller and the LCD driver. And this is a very interesting protocol because has some advantages, and one of the main ones is the reduced pin count necessary to connect such an application or such an LCD to your integrated circuit. The problem you'd be facing if you were using, say, parallel interface to connect your LCD while at the same time using a small integrated circuit or a small microcontroller, you'd be running out of space, and you'd also be running out of pins, and you wouldn't be able to connect any additional peripherals or sensors you want on your embedded application. And this is where the MIPI DSI comes into play, and makes it possible to reduce the pin use on your microcontroller. And then this led me to discover something I knew nothing about, of course, which is the two new IP blocks to me, the LTDC and the DSI host. So once I discovered this, after a long series of documentation reading, especially these two application notes, I was finally able to move on a little bit with my small project of controlling the backlight. So up till here, I had the basic three building blocks to move on. The first one is a stripped down version of the code. Second thing is understanding how the MIPI DSI protocol works. And the third one is understanding how these two additional IP blocks were working, the LTDC and the DSI host. And combining this knowledge, I started directly working on my code, and I decided disabling the LTDC. I also decided disabling the video mode that the DSI was using to interface with the LCD, and replace it with the command mode instead. And once that was done, I just needed additional information about the commands so that I could communicate with the LCD driver. Otherwise, communication would not be possible. So I checked the LCD datasheet and got the hex code and the parameters to manage or to control the backlight directly. So it's a really long datasheet. I wouldn't have expected it to be that complicated. But there's a lot going on an LCD panel, and I finally found my way through and found what I was looking for. So the hex code, or the hex codes for the backlight control or CABC control. And afterwards, using that combined knowledge, I added this portion of the code. So the LCD backlight toggle feature, very basic stuff. Sending command, the first command, to activate the LCD blinking or the backlight blinking, and the second one inside a while one loop in the second portion here to turn it off, and it was basically looping inside this while loop and turning on and off the LCD. And then it took me a lot of time to arrive to this, but I managed to turn on my my LCD finally. So, and it was toggling exactly as I expected it to do. So this whole journey was concluded with backlight blinking, and the blinking looked like this. As you can see there, every half a second, and it was blinking every half a second, and it still is blinking every half a second, and works exactly as I expected. So if I'm zooming out a little bit, this is the complete journey from the start to the finish on the LCD backlight, which is just like another type of LED blinking. Alright, I hope this video is somewhat interesting to you. If you have some comments, do not hesitate to add them or to submit them on the bottom of the video, and do not hesitate to subscribe if this is interesting to you. Thank you very much, and have a good day. Bye.